Okay, so we are on page, I think it's 36. And these problems, the directions alone seem a little bit confusing, but I want to show you really how these are just simply GCF problems. A lot of them you can do mentally if you practice your facts a lot. If I go through too fast on some of these, it's probably just an indication that you need to practice your facts and your factors. Maybe you'll want to watch this a couple times. And either way, I'm going to go through and show you really how easy this can be. So the directions read, like probably the hardest part is just the directions. It says write the sum of the numbers as the product of their GCF and another sum. So the first thing I'm going to do is just find the GCF. I'm going to find the GCF for all of them. Okay, whenever you see this set of directions, you can try this method here. So, and I'm just going to do as many of these mentally as I can. So for number 23, I'm just going to go through my list of facts, and I know that 8 goes into 56, and I know that 8 goes into 64, and I can't think of a bigger number that goes into both of them, and that does happen to be the GCF. So I'm going to find the GCF, and I'm going to put that first. I'm actually going to do that for all of these. We'll just practice our GCFs, then we'll come back and do the rest of the problem. I realize I haven't answered the question yet, but that's okay. Number 24, what goes into both 48 and 14? One thing I do is check, does 14 go into itself? Of course. Does 14 go into 48? And I look at my multiplication chart. It doesn't, so it's not 14. Think of all the other factors of 14. Includes 7. No, that's not going to be it. It's actually just 2. Sometimes the GCF is a small number. Number 25, what goes into both 30 and 54? So if I think about the factors of 30, 1, 2, 3, 5, 6. Oh, 6. 6 goes into 54. That's the greatest common factor. Again, I realize I'm going kind of fast, but I know that many of you are capable of going this fast as well. Be careful not to go too fast, though. On 26, some kids might look at this and think 4 is the greatest common factor, but it's actually 8. 8 goes into 24 3 times, and 8 goes into 45 times. Number 27, I bet it's obvious to you that the greatest common factor of 55 and 66 is 11. Number 28, maybe this one's obvious as well. What's a fairly larger number that goes into both 49 and 63? It's 7. The greatest common factor of things that end in 0 and 5 is often 5. And the greatest common factor of number 30 is going to be just 3. So now I have all my greatest common factors. I'm going to go up and reread the directions. It says write the sum as the product of their GCF. So right off the bat, I can now go through and say I'm supposed to write multiplication problem. So I'm going to put my multiplication signs in. And what are we supposed to multiply by? Check out what I do here. For number 23, I need to find the two numbers that the greatest common factor is partnered with to get these two numbers. For example, how many times does 8 go into 56? It's 7. And how many times does 8 go into 64? It's 8. And what I'm supposed to do is add those up, and I get 8 times 15. Now this second part that I did here is really semi-optional. You can kind of just leave it as 8 times 7 plus 8. But if I want to solve, it's 8 times 15. And then I'm not going to do this every time, but I'm just going to check to see that that makes sense. And here's how I can check. I'm going to first of all add 56 plus 64. That was the problem that was given to me. And that's 121. And I want to keep that in my brain for a minute. And I punched that in wrong. I knew that 121 wasn't going to work. It's 56 plus 64. And I get 120. Now guess what 8 times 15 is? You guessed it, it's 120. That means pretty much that I did it right. I'm not going to check my answer every time, but you can. So what did we do here? Well, we write some parentheses here, and we're going to write two numbers that the greatest common factor partner with to make 48. 2 times what is 48? It's 24. And 2 times what is 14? It's 7. And then we just solve the addition problem inside the parentheses. So it's going to be 2 times, and 24 plus 7 is 31. And if I were to check, 2 times 31 is 62, and 48 plus 14 is 62. How many times does the greatest common factor 6 go into 30? That's 5. And it goes into 54 9 times. And then I actually multiply 6 by 5 plus 9, which is 14. Number 26, how many times does 8 go into 24? That's 3. I add that to how many times 8 goes into 40? That's 5. And I end up with 8 times 3 plus 5, which is 8. 11 goes into 55 5 times. 11 goes into 66 6 times. And then I add up what's inside the parentheses, and I get 11 times 11. 7 goes into 49 7 times. And 7 goes into 63 9 times. And I add up 7 plus 9, and I end up getting 7 times 7 plus 9 is 16. 5 goes into 40 8 times. 5 goes into 25 5 times. I end up adding 8 plus 5, I get 13, and multiply that by 5. 3 goes into 63 21 times. 3 goes into 15 5 times. I'm 3 times 26. All right, we're going to check out one more problem here. Number 31 reads, explain why the greatest common factor of two numbers is sometimes 1. Well, it's not always 1. I can come up with a non-example. Let me come up with a non-example first, and then I'll come up with an example. And we will then use our example and our non-example to answer the question. So let's say I chose two numbers like, I don't know, 6 and 14. Just simple numbers. The factors of 6 include 1 and 2 and 3 and 6. And the factors of 14 include 1 and 2 and 7 and 14. And the greatest common factor here is 2. 2 is a factor in both lists. Now I know that's a non-example. Now we're going to look at an example. And I'm going to go ahead and make a little bit of white space for my video here. Cover this up. And I'm going to compare an example to a non-example, okay? Now I'm going to use one of the same numbers. I'm going to choose 6. But then I'm also going to choose, I don't know, 11. And it really wouldn't even have to be 11, but maybe I'll choose 15. No, that's not going to work either. I'll just choose 6 and 11. So the factors of 6 include 1 and 2 and 3 and 6. And the factors of 11 include 1 and 11. And if you notice those two lists, you'll notice that the greatest common factor is 1. And that's what the question is asking. It says, explain why the greatest common factor of two numbers is sometimes 1. Here's what I would say. The greatest common factor of two numbers that do not share any factors other than 1 is 1. And it sounds like, if you kind of understand the terminology, what a factor is, and what factors are, it sounds kind of simple. But that's really what we're looking for here. Is we need to get you to recognize that, hey, if the numbers don't share any factors, then the greatest common factor is 1. If they do share factors like 2 or 3, then that will be the greatest common factor. But sometimes the greatest common factor is simply 1, and it has to do with whether they share factors or not. Okay, good job. You are done with this portion.